it will deflect I cap minus j cap. So I think it should move in this direction now. It should move. We'll call V1 this is. Then the change in kind, in what direction this other ball should move. And I'll put it after collision, before collision. It'll be much easier. How the other ball should move? What is the possible direction you can move? Momentum should be conserved, no, for this. So will it move? Shall we put this velocity in this direction? Or shall we put this in this direction? I think this is very important. If I put in this direction, the momentum along y-axis will not be conserved. So if I choose this as possibility, or I can choose this also. Okay, agreed. This one. So let me just begin in this particular way. V2, I'll make it here. So this is making and u by 2 I cap. So this angle, I'm very sure it is 45 degrees, the way it is given. U by 2 I cap minus u by 2 j cap. Can we apply now? What is this? This angle of this, we don't know. I have the data. Sir, is it really balls can move? We are not very sure about what are the conditions, only just we have this much of information. Let's not bother. So is it a ball or a particle? If it is a particle, well and good. Since he said ball intentionally, let's not bother. How do they collide? Okay, before collision, after collision, we have information. I think like this, you have plenty of questions where during collisions, how their position, you need not to bother. Apply conservation of linear momentum along x-axis. So this will be 2mu minus 2um should be equal to 2m u by 2 only plus mv2 cos theta. This is the equation. So this should be equal to 0. This m will get also cancelled. So this will be u plus v2 cos theta. This is the equation 1. Keep it here. Then along y-axis. Initial momentum along y-axis 0. Final momentum must be 0. So that should be equal to mv2 sine theta minus 2m u by 2. So therefore v2 sine theta is equal to 1. Squaring and adding these two, we'll get v2, then we'll get the theta. Then we'll go for, we'll check the change in kinetic energy of the system. Squaring and adding, so v2 square should be equal to 1 plus u whole square. So v2 is equal to 1 plus u. 1 plus u sine theta equal to 1. Sine theta equal to 1 by 1 plus u. What about the change in kinetic energy? Delta K, we should write it as mv2 square.
Sir, v2 sin theta equal to u, sir.
v2 sin theta equal to u. Huh? That u I missed it, no? Yeah. That u has become 1. Okay, yeah, thanks. And now we'll simplify this. So squaring and adding, I think this will be v2 is equal to root 2u. v2 equal to root 2u, so theta will be 45 degrees. I think we are in now better position. m u square by 2, 2m u square by 2. To m 2u. We know value of v2. V1 value also know. We know the speed of this. Substituting that, we'll get the change in kinetic energy. I think this is, we should not bother about like, so during collision, how they will be. I think it didn't directly has given the conditions. So let's get into the numerical in this way. If delta K non-zero, inelastic. Delta K 0, it will be elastic. M by 2 will come outside. So this will become 2u square. V1 will be how much? 1 by 2. U square by 4, U square by 4 will be, I think, U by root 2. V1 will be, I think, V1 U by root 2. So substituting V1, M by 2 I took outside. So V1 will be U by 2. So this will become U square by 2. Yeah. Only will take M outside. M by 2, let me outside. So this will be 2M U square 4 mu square. There's a whole bracket. Phi u square by 2 minus 6u square. Check calculation. So, M by 2 we took outside, no? V2 is root 2, so 2u square. V1 is u by root 2, so u square by 2, 4, 5 u square by 2. That is okay. Final kinetic energy. Initial kinetic energy. Final will be less. Delta K, I got negative means final will be less here. Okay, this will be 2 sigma, 12 elements, so minus 7 mu square by 4. None of the options are coming, no? Check my calculations, fine. Is this okay? V2 by root 2 u. Okay, somebody. 2mv 1 square. Oh, the mass. Okay, there's the mass of this one, no? Here 1, 2 is missing. V1 is having mass 2m. Yeah, okay, that will become again u square only. Three u square. Okay, we are getting 3u square minus 6u square. M should not be there. Okay, thanks, Asita. I think we once again, I'm stressing the maximum will be troublesome for us, sir. What makes it to move? Let's not bother. His ask question, okay, we'll just work out. But momentum must become the difference. Sir, are they particle? What makes the balls to move? Maybe what happened, the line of impact will not be horizontal. Maybe the line of impact may be inclined. Therefore, after collision, they may move